Yeah, thank you for the invitation. And I mean, human-robot interaction is not exactly human-computer interaction, and you might have a slightly different focus in your series. I mean, but you could also argue that a robot is nothing but a computer on wheels. So you're right back there. And for all of you who do not know me, I started off working for the Lego company. I then moved over to Philips Research in Eindhoven and the Eindhoven University of Technology. I then moved to Japan to work for ATR for a while before then eventually settling at the HitLab in New Zealand. So I've spent quite a bit of the spectrum around the globe, but also between commercial interests, let's say, and more basic research ideas. And what I want to talk to you about today is robots. And this is an image of the robot building in Bangkok in Thailand, and it does exist. And this houses a bank. So a bank paid for the creation of this building. And I mean, this is bizarre, interesting, but it also shows the idea of a robot, that the robot would have a role in the future, and that it is a good thing this image is a good one, that a big bang decides to create its headquarters like that. I mean, that's a very strong message, really. But it also brings up, of course, an issue about how robots are being overall perceived by the media. So it's a blessing and a curse that robots get so much attention in our public media, because when participants come to our studies, they will have barely ever interacted with a robot before, and all of their knowledge that they have about robots is from television and from the movies and from books, and this is what is in their mind about what a robot is. And it's also in the mind of politicians when they formulate policies. This is what's in the mind of bank executives when they decide for their building. So while it is great that this line of research gets so much attention in the media, it also is problematic, because what people dream of in the future and what we are able to deliver are two very different things. And so I guess I should start off just with a couple of studies that we have done that are a bit more interesting. One of them was on robots and racism. So one of my colleagues, Rob Sparrow in the US, during a conference, he said that he was looking for an image of a brown robot that he wanted to use for his presentation, and he couldn't find any. So when you go to Google image search and you type in robot, then this is roughly what you get. And they're all pretty much white. Some of them are a bit more metal, but none of them are brown. And there are a handful of exceptions. Yes, they exist. But overall, it seems to be a consensus that robots should be white. And that is weird. Of course, people have argued, well, you know, my dishwasher is white, so what's the big deal? And then, of course, the question comes like, well, is a robot just a utility, like in your kitchen, a whiteware, or is it more than that? Is it actually a representation of a human? And when it is a representation of a human, why is it all white? And there's no real practical reason for it. And some people argue, well, it's easier to keep them clean or something like this. But I don't think that any of them were really designed for that particular purpose. It just seems to be a consensus, like robots should be white. And the people who develop these robots are also not necessarily all white. I mean, like robot developers, engineers, they also come from all over the world. And it doesn't even reflect, let's say, the ethnicity of the robot developers themselves. So why is that? So you could, of course, look at race as from an ontological perspective. And you could say robots themselves, they are a race. Or you could say that race is an attribution. So you could say all the green robots are a race. Or you could think about it as race as something that humans attribute to robots, that the concepts that we have for human-human interaction is something that we just project onto the robots. So our study was essentially inspired by an original work, and which was again based on the killings by police officers in the US. And so what these people found is that Black Americans were far more likely to get shot by the police over proportionally compared to their representation in society. And so they came up with this idea of a shooter bias task. And this is a very well-established experiment in psychology. So Cornell and his colleagues would present photos. And in these photos, a person would either have a gun in his or her hand, or a benign object like a can of a drink or a muesli bar or something like this. And the participants were put into the role of a police officer. And if the police officer sees a weapon, you're supposed to shoot. And if you see no weapon, you're not supposed to shoot. And these kind of images are put on the screen only for a split second. And the reason for that is that a lot of measurement instruments about racial bias don't work when you ask explicit questions. So if I ask any of you, how much do you like Germans? Then of course you would all agree with me that they're the worst people in the world. And you know, we could agree on that, but no, just joking. Explicit measurements don't really work, because if you ask somebody, are you a racist? The answer will of course be, no, of course I'm not a racist. Absolutely not. You know, my best friends have race. So you have to go to tests which work more on the subconscious level. And this kind of task where you have to make split-second decisions are then useful. These are implicit tests. And so the research question about we had is, do people ascribe race to robots? And if so, does that change their behavior towards the robot? And then will, in this paradigm of the shooting game, do they make faster decisions when they see either a black or a white robot? Do they make more mistakes? For example, are they more trigger happy? Do they shoot more often when they shouldn't have? And also, are they better in terms of their accuracy, so that they, you know, there are two types of errors they can make, right? So they can shoot a person that doesn't have an object in their hand, and they cannot shoot a person that does have a gun. So the type of errors they make are also interesting. So overall, this was an experiment where you give them a response window of approximately, we actually did two studies, once with an 850 milliseconds response window and one with 630 milliseconds. And it was a two, which was either human or robot by race, black or white, times weapon, gun, or benign object. This was kind of the setup of the experiment. And then we would have a white robot and a brown robot. And when we talk white robot, it doesn't actually make sense to have a white robot, because, you know, okay, I'm Caucasian, I'm white, but I'm not white. I'm not white, right? So that doesn't really make any sense. So the white is a Caucasian white, let's say, and the brown is a brown that we sampled from actually a photograph of different type of skin colorations. So yeah, we colorized the robots. And so here you have an overview of what the stimuli would look like. So the robot would either have a gun in its hand or a soda drink. And we reused the exact same backgrounds that was used in the original experiments, just kept everything stable. And we even used the original photographs that they used. So the same people, everything the same. So we just reproduced the original experiment, and then we added another condition to it that was made of robots. And we did also include an explicit measurement, and we just asked people, what race does this robot have? And this does include the option of does not apply. And so what happens is you give them a fixation point, you then show them a couple of random backgrounds, then you give them the target image and they have to press on the keyboard, either A or L, and we measure latency and accuracy, and then they get feedback whether they did correctly or incorrectly. Again, this is just doing the exact methodology as it was originally proposed. And the results show when you go for the explicit measurements, it was only around 10% decided to choose for the option does not apply. Everybody else chose a race for the robot, which is weird, because why would you? I mean, you could literally say like, no, it's not a race. Robots don't have race. This is silly, right? But they don't. And then again, they do roughly 70% when it was dark brown, it was given the black, and when it was Caucasian white, it was descent white, and there's a bit of random noise around it. So that in itself is curious that people don't use this option, does not apply. When we then look at latency, there is a significant interaction effect between age, race, and weapon. I'm kind of trying to summarize and not bore you with the statistics here. Overall, we could show the presence of a shooter bias. So people acted differently towards the brown robots, similar to the way that they also act towards humans. So essentially, whatever racial prejudice people have, they mirror that with robots. Which again is weird, because most of these people will have never ever worked or interacted with the robots. They've only seen it on TV, and it still works. So robots are being racialized, and people change their behavior accordingly. So what this really means is that we cannot not design it, right? Even if we decide, oh, actually, I don't want to get into this whole race thing. I don't want my robot to have a race. I just want this to be a robot. You cannot not communicate. So people will ascribe a race no matter what. And it is your responsibility to get this right. And if you're thinking about deploying a robot, let it be in any country that is predominantly not Caucasian, it would seem very weird to me to make them white. I mean, why would you have a white robot, let's say, taking up a teaching position in a rural school in India? That doesn't make any sense. Why do we not give, many or create brown robots? There's really no reason for it. So yeah, that was a surprising result. Another thing I want to talk to you about is lexical entrainment. So the idea here is that if you have robots, why is that there? Oh, that's not supposed to be there. Sorry, I don't have the presenter screen right now. I'm sorry about that. So I'm always a bit surprised about my own presentation here. Okay, so I'm not sure why this slide is in there. But what I wanted to talk about is we recently published a book, Human-Robot Interaction. It is also available as a free PDF download. Cambridge University Press was so nice to allow us to put the PDF online. But one thing that happened when we worked through this book is that I created this kind of timeline of all the social robots that we mentioned in the book. And when I looked at it, it seemed that all of them are dead. None of them survived. So it was more like a graveyard, really. And so the question came up, why do all these robots stop, like Honda. I mean, they've been going on for a long time, and then they decide to stop. So another example is the Jibo robot. I mean, we just right now, was it last week? Amazon brought out a new robot. That's going to be an interesting one because function-wise, it's almost on the level of Jibo, except that it can actually drive around, but it doesn't do much more than Jibo. And as for Jibo, one of the most highly crowdfunded robots in the world. It raised, I think, overall, well, around $3 million US. They got a lot of capital funding. They had people from the MIT were coming on it. They actually produced the robot. They actually got it to work. They shipped the product. You know, they did everything right. They did everything you could do right. They did do right. And here's Cynthia actually advertising the robot.
Jibo, please introduce yourself.
Sure. Hi, my name is Chico. I'm the world's first family robot.
Yeah, so I mean, this is actually, we developed several prototypes on the road to where we are right now. And certainly we've done testing all along the way. You know, we very quickly found, and this is just reinforces a lot of what I found as my work at MIT, people want to treat Jibo like a someone, not a something. And they often...
A someone, not a something. That's an important one. They made it to the cover of the Times magazine as the best invention, right? I mean, how much better does this get? And then it kind of flopped and the sales were pretty bad. And after, I think, 1 or 2 years in the market, they stopped. And this is an example of a review that this robot received.
In July 2014, man did not yet know the dangers of backing just any random Kickstarter or Indiegogo campaign. And swimming in childlike naivety and blind optimism, over 2,500 people backed Jibo, a social robot companion that the creators, Jibo Inc., promised would do everything from making video calls to reading bedtime stories. And this was long before the Google Assistant or Amazon Echo existed. Now, for my part, it was pretty obvious that Jibo was too ambitious to be anything but an enormous belly flop onto a bed of hot coals. But coming off of the success of my then recent flaying of the Brunton hydrogen reactor, I was looking for a way to up the ante. I was looking for something even dumber to roast. So I bought one. 3.5 years later, my very own Jibo finally showed up. Was it worth the wait? Was it worth $900 US? Of course not. Don't be a Jibo. This video was...
So as you can see, it didn't come down very well. And after a couple of years in the market, they stopped and went pretty much belly up, which is pretty sad because, again, they did everything right. I mean, what else was missing? I mean, everything was done as good as you could do it, and it failed. And this is, again, going to be very interesting when Amazon now is releasing it. I mean, they're probably swimming in so much money that it doesn't really matter to them. But so it's going to be interesting whether it's going to be any different. Anyway, if you think like, okay, well, you know, that's just another one, but no, it isn't. So then entity disruption stepped in and bought up any kind of remaining IP from the company. So Entity is the Japanese telecommunications company, and they have a new department called Entity Disruption, and they're doing all sorts of disruptive things, and they bought up Jibo. And so they made a video clip about what they're going to do. And so I could not possibly withhold that from you. So here we go.
It's what a word. To you, there's no till where, no till here. Impossible, unthinkable, crazy thing. All those words you deal with every day. They don't annoy you, they inspire you. They don't shut you in, they set you free. Listen You need limits to be who you are, to disrupt, to create, to invent. You, the old rules breaker. You, the new rules ruler. You don't live in the real world, some may say. They just ignore this world of theirs is changing. And thanks to people like you, like us, like her, change is happening for good. We, the people who see things differently, those who say no to no. You are just a few, some may say. Yes, we are. But those few will create today what really matters for tomorrow.
Yeah, so what this points at is that this is predominantly marketing. So when it was even argued that when Sony came up with the iBudok twice, it was predominantly done as a form of boosting the value of the market. So if you give yourself the image of being an innovative, disruptive company, then your shareholders will love that and prices will go up. But it's quite doubtful that they're going to really do anything with it. I mean, I asked them specifically what their plans are and what are they going to do different than what has been tried already with Jibo? How are they going to bring it to the market? How is it going to be different? And the answers I received from them was just like, oh, we're going to focus on business to business and not to end consumers. And that's it. I mean, the rest was the same. They still wanted to go for education and caring and home assistant, everything they wanted to do before as well. So again, it's always sad when these kind of products are just being used for their marketing purpose instead of trying to make some actual progress in the field. So I created a little bit of a podcast episode on that, and I interviewed quite a number of people. So if you want to listen to that, please go ahead. It is reasonably entertaining. And this is the press release that they put forward. The company has strengthened its portfolio and social cognitive agents, aiming to improve people, so forth. Again, it is predominantly marketing speech. But even if we look at one of the best-selling robots that we have, which is now called SoftBank, it was originally called Aldebaran. But when Aldebaran was bought out by SoftBank, which again is a big originally a telecommunications provider in Japan, they built these Unite robots and they put them in all of these stores in Japan. These are mobile phone stores. And it was a gimmick, it was something to get people into the store so that they can sell more phones. And for that alone, it might have been good enough, but it's also being used and opened up for people to do research. And this is one of the more popular platforms. Whether this is a success financially is a bit doubtful. A couple of months ago, there was the news that they stopped the production of this, claiming that they just couldn't sell enough and they just paused whatever supply chain problem, whatever they might bring forward. But again, the real question is like, who buys these things? And the answer is, well, it's just researchers. I mean, how many researchers are there? And how many do they need? And how long do they last? When do they break? So the market that you have is actually pretty small, because here in Christchurch, they tried it as well. So they always think like same, but different. So if we do the robot, yeah, it's the same thing, but when we do it, it's different, right? And it's this kind of bias that we have in our head. So here in the airport Christchurch, they also thought like, hey, we buy these robots, everything is going to be different. So they bought these Pepper robots, put them in the terminal. They figured out that they are pretty useless and they can't really do anything. And now they're rotting somewhere in a building, somewhere in the basement probably, and will be forgotten about. And while this is a learning experience for this organization, so they learned something about limitations of AI and limitations of robotics, they could have also just downloaded the free book we make available and read it, and then they would have known the same thing. It is just mind-boggling. But again, it's this mindset like, when we do it, it's going to be different. Same thing with Sony's iBudok. I mean, they when they brought the dog out on the market in 1999, it was a big uproar. It's like, oh, finally robots have arrived. And they ran it for a while and then they stopped it due to a reorganization. And I talked to the people actually who were developing ARIVE at the time, particularly the research group in Paris who was working on the AI. And they said, no, look, it wasn't a financial problem. They were making money. It was something about strategy, how this, you know, an American had taken over the leadership of Sony, you know, before it was over the Japanese person, and he essentially chopped anything that wasn't core business, and so it was gone. And a lot of people were very upset about it. And I think a year ago, Sony brought it back, so now we can buy again a robot. And again, last week, Amazon came out with another one, so that's going to be interesting. One of the few examples of robots that did work and consistently work, and they're still in the market, is the Paro robot. So this is a sealed robot. And really, it doesn't do much. It just wiggles a little bit, it purrs, and it has some sensors. So when you stroke it, it kind of can sense that and it can purr then, and that's it. There's nothing more to it. And the interesting thing here is like, well, why would anybody buy that? You know, and the reason here is that, well, nobody's ever interacted with a seal. I mean, have you ever petted a seal? Okay, in Christchurch or in New Zealand, maybe, but in most other countries, probably people would have not had any kind of direct encounter with a seal. So people don't know what seals do. Like, do they purr even? Can you pet them? How would they react to when you pet them? Nobody knows. So anyway, but it is a cuddly, nice thing toy, and people respond very positively to it. And particularly, this has been applied in elderly care, and it calms elderly down. And you know, it's not as demanding as a dog or a cat would be. And so it has its niche, so to speak, in which it actually worked. And of course, like utility robots, like cleaning robots, that now also works, where the robot has a clear function, where it actually does something good. So Aibo, other than entertaining, doesn't do anything. The Aldebaran, SoftBank's robots, now Pepper, they don't actually do anything. Now, when we look at the robot from Amazon, Astro, it's called Astro. Essentially, it's Alexa on wheels. Does it really do anything other than what an Alexa would do? Well, yes, it can drive around and deliver drinks. It has a little pouch in the back where you can put a drink in. So there is maybe something to it. You can tell it like, okay, bring this to wherever, my wife, my daughter, wherever. So there's a little bit of a function there. So the real hard underlying question is that over the years, we have been making progress in terms of the intelligence of robots and AI. And that's undeniable. They've become, you know, our AI systems have become better. And we can increase putting effort into it. And the magic question is, because we might be in a situation of diminishing returns, that no matter how much effort we put into it, it will never be good enough. And nobody knows whether this is true or not, whether it's really just a question of time, put more resources and more effort into it, and we will get there. Or is it something that we will never get because maybe there are some conceptual problems about why this just can never happen. So, I mean, this is again, predominantly for the market. When we do our experiments in the laboratory, we very often do Wizard of Oz type experiments where we fake intelligence, right? And then we can overcome these problems, but that's for purpose of research only. And it's not really good for when you deploy it for real. So this is an example of a robot that we did. And so we took a shortcut. And this is, if you have to have a conversation, meaning is a problem, like that, well, what you say actually relates to what was said before, and that it is meaning. So one way out of it is mysticism. So if you just talk like Buddha, it doesn't matter what is said, it always sounds smart. So we filled these couple of robots with the Bible, the Quran, and a book from the Hindu religion. And we just then created chatbots, and let's just let them talk to each other. And this is then what you get.
And then
let's see if I can
here chatbots compete for you
a bit forward.
And focus.
Okay.
The major religions are widely acknowledged examples of mystical topics. We selected the New Testament, the Quran.
Okay.
The robots are able to autonomously talk to each other and to humans about their religious belief. Each robot represents the belief, but we don't reveal their convictions. This ambiguity forces observers to follow the actual conversation instead of quickly applying stereotypes.
Lords of all riches, dwelling in the home of wealth, endowed with mighty vigor, singers loud in voice.
And when the voice was past, Jesus was found alone, and they kept it closed and told no man in those days any of those things which they had seen.
And yet, as who has created the heavens and the earth with truth? And on the day he says, Be, it is. His word is the truth, and his is the kingdom on the day when the trumpet shall be blown.
Well, you get the idea. It is escape rationality by being deliberately mystical, and that way you can overcome this problem. Or Wizard of Oz, pay no attention to the man behind the curtain, right? Just fake AI, and it works fantastically. People have very little filter about this. And when we afterwards reveal to them, look, this was actually not a robot, this was actually us controlling the robot, they're quite often surprised. Because again, these expectations that they have from the movies, from the TV is so strong that you can easily make them believe that the robot is actually able to do it and barely anybody doubts it. So another way to go about it is just to say, it's not a bug, it's a feature. So the fact that robots are repetitive, that their vocabulary and abilities of acting is very limited. For some people, this is like, I mean, if you give it to a person, this gets very boring very quickly. For some people, this is actually great. So people with autism love this kind of predictability, this repeatability, that it's just always the same and it's predictable, that works for them. And so again, we found, we had a solution, we had a solution and now we found a problem that we can solve with it. But as it is with research, one thing will happen is it will never be finished. So we will never write a paper that will say, we believe this resolves all remaining questions on this topic, no further research is necessary. That is never going to happen. We'll always have more questions and it will just continue on. And as a matter of fact, if you ask me, I'm a fiction writer in the grand proposal genre. That is part of my job. But the power of it is quite interesting about fictional beliefs and science. So I just have to play this one back, I'm sorry.
And then I said, supposing you brought the light inside the body, which you can do either through the skin or in some other way. And I think you said you're going to test that too. Sounds interesting. Right, and then I see the disinfectant that knocks it out in a minute, 1 minute. And is there a way we can do something like that? By injection inside or almost a cleaning, because you see it gets on the lungs and it does a tremendous number of lungs. So it'd be interesting to check that. So that you're going to have to use medical doctors with. But it sounds interesting to me. So we'll see.
So ejecting bleach to kill COVID, if a president says that on stage, that says a lot about the relationship between the ideas and the imaginations of politicians about what science is and is not compared to reality. And when it comes to AI and robots, this is unfortunately happening quite often. People get carried away with beliefs about what these things may or may not be able to do. This is another example. This was Christchurch mates. They came up with ZAC as this supercomputer, which is supposed to do a lot of things. So here's an interview with the creator of ZAC, the supercomputer.
We're going to remove the people from the equation everywhere the customers full. put a machine in charge. So the idea is take the links out where we've got a human involved, replace the machine and see what happens. So is it going to be a colossal disaster or a success? We'll find out. We're taking away the management team, we're removing the board, we're taking away the accounts people, product procurement, configuration, provisioning, customer support, social media management, all of it. And we're going to give it to a computer program and see what it does. But beyond that, we're not going to watch it. We're not going to stop it. We're going to let it do what it wants and what it sees to be fit, provided it can present us with a reason for why it's doing it. So if it wants to terminate people's accounts, why is it doing it? If it doesn't want to connect with people, why does it want to do it? All those sorts of things. So there'll be a human oversight, but we're not going to watch it. We made terrible talk for one simple evaluation reason, one to see if.
So the interesting part is a 25-year entrepreneur promising a supercomputer that can all of these AI things is enough to trigger off the imagination of people about what AI can and cannot do. And here's the medical doctor that used this supercomputer in its practice, where the idea was that the supercomputer essentially listens to a patient-doctor interaction, then summarizes what was talked about, and even gives the recommendation as to what possible treatments could be.
So we started off to train Zach and were amazed by his ability. In no time at all, we trained him to take notes in SOAP format. That's subjective, what the patient said; objective, what the doctor found; assessment, what the doctor thought the findings meant; and a plan, which speaks for itself. And this is the standard format criteria set by the Royal Society with England and one a recently graduated general practice registrar who just completed communication.
So then they actually ran an experiment in which they compared the note-taking of Zach to professional people note-taking and see how good it is. And they came up with that Zach, the supercomputer, is actually better than human people doing this transcription. And then they were out to essentially raise funds to get this done. And of course, it turns out that all of this was just nothing but an illusion, that all of the interactions with Zach, the supercomputer, was actually nothing else than an interaction with probably a person. This was actually a reverse Turing test where there was no intelligence in the back. So when the doctor would actually send the audio file, there was a human in the background transcribing it, right? Or when the interaction was happening with it via email, it might take minutes or half an hour or even a day before the supercomputer responded. The good news is that there was no real money wasted, and the only effect that it had, that two people or the family, a father and son who did this, were banned from opening a company in the future, but there was no actual money wasted. So that's on the plus side, but it shows how much we want to believe that what AI can do. And then we got Amazon Alexa here. This is the version 10, which the screen can rotate and move around and follow you, which is again a robot. Now we've got Astro, which does this already. So the one thing that robots can do, which speech assistants can't do, is touch. So, and manipulating the world. So again, Astro does not have a manipulator arms that cannot grab anything, but it can at least drive around and deliver things, so which is already something. Roomba robots can clean the floor. But for social robots, the trick really is touch, because that's the only thing that sets it apart from a conversational agent, as you know already. So we did an experiment where we looked at tickling, because it turns out you can't tickle yourself. It requires somebody else to do it for it to work. And so we had this experiment where either the robot would do it, another person would do it, or you would do it yourself, and we measured like, well, how ticklish is this experience? So I think this is where the real interest comes in. And this is an example of, again, I brought the robot home, Papiro from NEC. I just literally took it out of the box, put it in my home, These are my kids and a friend, and it's completely unscripted. This is just what happened. So for one reason or the other, my kids decided that the most appropriate interaction with this robot is to kiss it, right? There was no instructions for it. The robot, it's not even meant to be that. It has LEDs on its mouth that can light up, but that's it, you know? So the power of it can be very, very, very strong. And it comes back to this question about how much intelligence do we need these robots to have in order to succeed in the market? So if you're interested, have a look at the podcast. It is full of interesting episodes, as some of you have discovered. We've also now launched a professional certificate in human-robot interaction on edX. There's a course that you can take for free. So please have a look at that. And if you're interested, take this course. We've also recently published 2 other books, an introduction to ethics in robotics and AI, and this is now the German title, but there's also an English one, Robots in Education, where we particularly looked at how robots can be used in education. And with that, I'd like to thank you and take your questions.
Thank you very much. So as always, if you have questions, you can either unmute yourself directly or raise your hand using the Zoom options. Holger.
Thanks, Christoph. Very, very interesting, inspiring talk. Thanks a lot for that. So one shorter question and one longer. So the shorter question is, did the tingling work with the robot or not? So that, because you didn't reveal that, I think.
It's been so many years, I don't exactly remember. I don't remember. But see, the thing is, again, the Now robot is pretty useless. So it doesn't even have, like, say, a force feedback sensor. So, for example, that could regulate the amount of pressure it executes. And so this little device that we put in there was actually kind of in between, so that it doesn't hurt anybody because it's so bad at it. So a real massage robot would be really difficult because it would have to sense, you know, where is the muscle, you know, where do I have to press? It's a really hard problem, and not really, never do that. Yeah. So I don't have a good answer. I just don't remember right now what it was. And the longer question?
The longer question is actually, so now with all your experience in human-robot interaction and all that, you know, you come to the conclusion that most of them probably do not work as intended, right? They are not effective in the way they are invented. So where's the future? Where's the human-robot interaction future, right?
Yeah, that's a very good question. As I mentioned before, there's always, every paper ends with further research is necessary. You know, that's how every research paper ends. And so this will just continue. I don't have any doubts on it. And I think also that there is enough, let's say, fascination with the topic that people will also continue to support it financially for grants. We are held back predominantly right now by software. That's the limiting factor. So AI, that's the limiting factor. Okay, you could still argue batteries is still another thing. I mean, like any kind of experiment, these robots, they last for half an hour, for an hour, and then they need to recharge. That's not the kind of activity you might really need or want in your home. So management of energy is another really big issue, but the real issue right now is and will remain AI. And the whole field of HRI is held back by this. And all the predictions about how whenever we will have a strong AI, I mean, we're supposed to already have it like years ago from the original predictions, and we don't. So I think this is just a terrible, terrible, difficult topic, and I don't even dare to make a prediction.
Thank you.
Thank you. Stephen?
Yeah, thanks, Christoph. Really, really interesting talk. I'm just wondering, is it just a question of how much money you need to spend to make a good robot? obviously all these social robots that are in the marketplace, no one's going to pay the kind of money that DARPA will fund people to develop, and artificial pet carriers and things. And I mean, those robots from Boston Dynamics and so on seem to be pretty competent. I don't know how social they are at this point, but they're obviously very useful. Is it just a question that we need the technology to get somehow cheaper?
Yeah, so Boston Dynamics is an interesting one. I'm almost tempted to make a whole podcast episode about them because they are surprisingly old. I mean, they've been in the market busy for like at least 20 years. And they only ever, as far as I know, brought one robot to the market, which is the Spot robot, this dog robot they released last year for $75,000 US. How can you actually run a company for more than 20 years without selling a single product, right? And of course, it was all just attracting investor money, research money. It seems to me, how they survived. But there's nothing to sell for, it's nothing to show for, right? And originally, of course, a lot of funding came from the military, and they thought, oh, we can build this robot that can better deliver or transport things in the field because, this legs are better than wheels in the field, But then it turns out that the motor that they had on it is so loud that it would immediately give away the location of any soldier because that thing got so loud. So they moved to electrical, but then you've got the problem like, how much juice do you have and how long does it last? So there's a lot of practical constraints. And again, the Spot robot that they released right now, yeah, for research, it's going to be interesting. But what is it really going to do? I mean, who really has a function or use for it that will make it worthwhile? Because if you take the Christchurch airport again, and let's say you have a robot there, which is some sort of information booth kind of person, you can go up to it and you can talk, ask a question, it could answer. And the advantage potentially is that this robot could understand many different languages. So therefore, an advantage over a human person. But then again, you need at least probably 2 engineers in the background to keep this machine operational. So commercially, does it make sense? Wouldn't it just be cheaper to have a person there with, on a lower salary? It's probably going to be more cost effective. So again, we don't have it so often that a major company with deep pockets goes into it. So Amazon is going to be really, really, really interesting. Because they announced their robot's going to cost, I think, $1,500 US. And let's see whether they open it up so we can actually maybe use it and program it and do things with it. And again, I guess the problem with AI, and particularly with conversational AI, is like there's no real way of having good conversations with it. And the Alexa world, let's say, the platform itself already is a market. So you can actually, any developer can create a function and then publish and sell it on any Alexa device and make money that way. So I guess the idea here is that if you have a large enough user base, so all the Alexa devices, then it's interesting for developers to develop functions that they can sell on this platform. So I think Amazon might have a shot here because their ecosystem is already so large that maybe they've surpassed the critical mass so that it's worthwhile to develop content for it. And then maybe it becomes attractive. So I think it's going to be a really, really interesting example.
Christoph, thank you for the talk. Sorry, I did not
raise my hand,
but a question. Can you hear me?
Sure.
Yes, yeah. So interesting work on racism and robots. Did you do the same for gender as well? Or is gender assumed to be male for robots?
Good question. Not me, but some of my colleagues have done these studies. They looked at where their gender is assigned. I don't exactly recall the results of it, but I know it has been investigated. They've also done other experiments. So for example, they would, again, show the same robot and they would say, and this experiment was done in Germany, and they would give the robot a German sounding name and say it was developed at the University of Bielefeld and it's all German. Or they would tell the participants, okay, this robot was developed by the University in Istanbul in Turkey, and they would give the robot a Turkish name. And people would react differently to the robot. So again, same robot, no difference. And it's just our stereotypes are being projected onto it. And even if it's just a name, it is there. And what it really means is that robots are not a dishwasher. That, I guess, is the take-home message here. It's not just a dishwasher. It is a representation of something that is human-like. And with this representation comes all this baggage and potentially also a lot of benefits. I mean, you can also use it for good things. But the point is, if you just consider a robot to be a dishwasher, then you're wrong. I mean, a dishwasher is definitely a robot. It has sensors, actuators, programming, chips. It's definitely a robot. But it is something else than something that has this kind of in-between status where, yeah, it's not a human, but it's not a machine either. It's somewhere in between.
But actually, with a dishwasher, we are probably maybe not racism, like you said, many of them are white. But for example, the problem of you have a Miele dishwasher, you also apply certain German character traits to that. So my point is, even a dishwasher, we project our stereotypes onto that. So even a dishwasher is not that completely neutral thing. I would argue. Sorry, maybe you have a different perspective on that.
So Christoph, if I may ask, just I was thinking in terms of the biases. The human biases are now being taken to the digital form and to the robots. So is there any work on mitigating biases? Your work shows that there are these racial biases. So going forward, what should be done? This is clearly, humanity hasn't found a solution to this, for humans. But is there a need for such a thing for robots? And where to next? Because you've established something is relevant, and the bias exists. So where next?
Well, I guess the first thing to do really is just to move away of always making them white. Just stop making them always white. I mean, look, in a couple of years ago, the whole emoji discussion came on about why are all emojis yellow, sort of representing Caucasian. And it took a while before they acknowledged, no, we should actually have all the emojis in a variety of skin tones to better represent the people. And the same thing has to happen for robots as well. We must offer choice. We must offer diversity. The problems of how can we overcome racism and racial bias, yes, I agree with you. This is a really big problem, a very difficult problem. Yes, robots could potentially help with it. But since robots are so rare and so not yet available, I think we should better start working on it now through different means.
Thank you.
Okay. Thank you very much, Christoph, again, for the very interesting talk. And I'm sure there are more questions, but I would like to direct everyone to your email address and to ask them directly to you. Again, thank you everyone for joining. We will have to close because we are at our time limit. And I hope to see all of you on Thursday for our panel discussion on the future of XR.
Right,
thank you again.